So let's talk about these double complexes. So what are these things? So these are double complexes. So there's kind of two directions here. Maybe I didn't need to do parentheses there, but here, let's start with B0, 0. Okay, and then we'll go up B1, 0. So there's kind of a D up direction. And you can do it multiple times. B up. Okay. And it keeps going. And maybe this kept going too. So there's things on this side. And what I did say is that there's a D over direction. So a D right. And this thing increases the other index. You know. And in both directions, these are complexes. And then from here we can go up, up. And when I'm writing this here, it's not necessarily a commutative diagram. So this is a 2, 1. It goes up forever. B2, 2. And when I say that it's not a commutative diagram, B1, 2. I mean that I'm going to have it anti... So there's kind of two flavors you can do. You can have this relation that says anti-commuting. This is sometimes convenient. Here. We know that, first of all, we should say that D this thing squared is 0, and D this thing squared is 0. Okay? And so sometimes people... so there's a kind of a remark here. Sometimes... people like, let me call that star, like the condition that these things commute rather than star. And if this is the case, letting, let's say D over, and let's say this is in the ith piece. So if we modify this, so I'm going to make a new over direction, and what it's going to do is it's going to multiply by -1 to the I, D over the usual ith one. So the ith one will be this piece. Maybe I should have called it J, so it agrees with the other piece. Okay, so then this should be like that. Okay, so if we do it like this, then we get this condition. Okay, so by changing the D arrow. Okay, so we have this double complex, and we can look at spectral sequences associated to double complexes. So this is what I was saying. So at this point, we can look at spectral sequences. So I still haven't told you what this sequence is associated to double complexes. Or tell you about the filtrations on the total complex and that will induce this guy. Induce these sequences. Okay, so what I chose to do first is just to show you the double complex. Okay, so let's compute an example. So again, let's let T be the total complex of some double complex. let's let F on T be the associated, the filtration induced by this stupid filtration on the double complex. And so, and then let's just compute what the graded pieces look like. So the graded piece of let's say the pth graded piece of the total complex here. So this is equal to, let's do for the nth guy. Okay, so this is the same thing as equal to the grading. We'll take the associated grading and take the pth piece. So this thing is equal to so this is, we do the filtration P of Tn modulo the filtration of P plus 1 of Tn. And what this turned out to be equal to was, this was the sum of I plus j equal to n, and then we required j to be bigger than or equal to p. So this was of t, or we call it b I j's, and then this is modulo, and this piece over here, this is equal to the direct sum of I plus j is equal to n again of bij, and except for now in the lower part, we need j to be bigger than or equal to p plus 1. Okay, I got some water. Hopefully my voice is a little bit better. Okay, so this one here, this is the direct sum of let me skip that direct sum thing. So this is so just this j piece needs to be bigger than p. So this is b, and then we have j. So they need to add up to n. So the lowest one we can have is there, and so then since they need to add up to n, this is n minus p. Okay, and so then we have b n minus p minus 1, and then we can go bigger on this side, go bigger, go home, all right? Then we go all the way up until the second component is n, and this one's n minus p, let's see, oh, this is 0, goes all the way to 0. Okay, and then we divide out here, and this is equal to, oh, okay, so now the other one can go a little bit bigger. So we have n minus p minus 1, and then we have p plus 1. So it doesn't get to go bigger. It actually gets smaller because those two match. So this is b, and then we have n minus p minus 2, p plus 2, so on and so forth, all the way when we get to b 0n. And then it turns out that these all cancel. And what we're left with is this thing being equal to, or isomorphic to, b n minus p. So in conclusion, for this one, so the pth graded piece of the total filtration of n, well, this was just n minus p, b n minus p. Okay, so that's cool. It'll turn out that in our spectral sequence, okay, so that's all I wanted to say about this. So I want to continue with the double complex. So let t equal this direct sum. So that's Tn. And let's say Bij be the total complex of a double complex and with the let's say horizontal filtration And we'll say that we'll call it f of q of Tn. This is going to be defined to be equal to the direct sum of bij's, where I plus j is equal to n as usual. And then we're going to say that j must be bigger than q. Okay, so our claim is that the map on E0 PQ, which is just equal to BPQ, is just the horizontal map, or just the vertical map. Okay, so we're recalling that this double complex, right, has two directions, up and side, and we have this, d up, d side, and that d up, d side plus d side, d up is 0. Okay, so this is the claim, and we're going to do a proof by picture. So whenever we can do proof by picture, it's the best. Okay, so we're going to draw this. So I'm drawing a bunch of dots here. If you can't tell, I'm drawing dots. More dots. We need more. More. Okay, I'm going to do a couple more. More. Okay, lots of dots. Lots and lots of dots. Okay. Oh, I probably should have done this with the lines. Okay. Anyway, so we have this this Bij deal here, and so what we want to look at is we want to look at FQ Tn. So here, well, what is FQ really doing? So, okay, we go down to some number here, Q, and what FQ does is it picks out this, and then it has all these parts are good. Okay, so this is the part, this is FQ of this huge complex here. Okay, and so we can take a particular Tn. So if we take Tn, Tn for some n, let's say n is going to be bigger than q, so this is going to be some Tn here. And what FQ of Tn, so let's look at that. Blue. No, I already did blue. This thing. So FQ of Tn, so that's going to be all the good part here. So this is FQ of Tn. Okay, so FQ of all these other ones are here. And then we can look at FQ plus 1 of Tn. So let's do purple. And let's do this. So FQ plus 1 of Tn. So if we do Q plus 1 is here. So then it's so what this is it'll be just this piece here. So maybe I can do something like, maybe I should have done Q plus 1 like this, and then had it here, and then this is this. So it's going to be all these pieces here. Okay. So then FQ plus 1 is here, and so in particular, it's going to kill this stuff's going to be dead. So let's look at what happens when we do D on this thing. So the induced D at this point is here and here. So up and sideways. But if we're modding out by FQ plus 1 in the image, so this thing goes to FQ N plus 1 over FQ plus 1 Tn plus 1 here. So here, the Tn plus 1 is along this strip, and this part gets killed. So so what this says is that the total derivative restricted to this piece, restricted to E0, let's say PQ, okay, because that's what this is. This is E0. Okay, so in this case, N is P plus Q, and then this dude here is E0 P plus Q, or P comma Q, which happens to be the graded piece associated to the filtration, the qth graded piece of the total P plus Q. Okay, and this also happens to be equal to B of PQ. Okay, so this is what we showed this before in another guise, and then I maybe switched the letters, and then so this is equal to D up. Okay, so sometimes when we do this filtration, the horizontal filtration, this leads us to the complex where this is also the horizontal filtration gives a spectral sequence. So what this says is that the horizontal filtration leads to the spectral sequence of the double complex starting from the first, starting from the vertical arrows. Okay, so that's all I wanted to say about that. So before moving on, I want to do a couple sanity checks. Sanity checks. Okay, so one thing I want to do is straighten out the difference between this horizontal and vertical direction in the double complex. So so let's look at what E0 PQ is. So E0 PQ. Okay, under the official definition, we get D inverse of F P plus R, K P plus Q plus 1, intersected with the filtered part. So remember we filtered this. So again, this is a modification of the pth gradation. D F P minus R minus 1, K P plus Q minus 1, plus, and then again, this is a modification of the pth gradation thing, P plus Q. Okay, so in the case that R is equal to 0, this goes away, and this goes away, and we can note that this thing here is completely contained in here. This is, or it's going to be completely modded out by here. So modding out by this is modding out by more. Or let's see, sorry, hold on. This is FP plus 1. Oh yeah, sorry, that's not the case. Sorry, this is P plus 1 here. This is contained in here. So that's nothing. Okay, so then all right, so that does nothing. So the denominator is Fp plus 1, Kp plus 1. Okay, and then the numerator, let's look at the numerator for a second. So D inverse, so this goes away. So this is Fp, D inverse of Fp. And this is also D inverse of Fp. This is contained in Fp. Okay, everything that's in FP is comes from FP. So okay, so well that does nothing. This is Kp plus Q. So they both do nothing. Do nothing. Losers, as Donald Trump would say. Okay, so this is equal to, so we can just see that this is the pth graded piece of Kp plus Q. Okay, this is nice. Okay. And then the map, again, we said that the map here from E0 PQ to, it goes from E0 to P plus 1 Q. And this appears, let's see if this is the right thing. I might have this wrong, because I always get this backwards. So, no, this is wrong. So, this is E0P, comma, Q minus 1. Q plus 1. Because we have, so the thing goes to, we subtract R minus 1, and R minus 1 becomes a plus 1. And that's where we get here. Okay, so we're actually, when we do this, and if we were going to write this in the situation of the double complex, we're actually moving this way. So let's okay, and then in the example that I did there, and then I actually wrote down the grading of Q, the total complex of P plus Q. So this is the way to go up, and the way to go sideways will be this. So let's just double check this. Let's do a little sanity checking. And when we do a little sanity checking, what do we get? So the grade, so let's suppose now K is equal to the total complex. So this is equal to the tote of, let's say, B, some bicomplex here. Okay? And then, okay, so and then we'll use now the other filtration here. So the filtration we use with the filtration where we take this dude, okay, and before we partitioned it down, but now we'll fix some Q. Let's say, yeah, we'll partition it like let's see. How will we partition this? Well, let's just do it. This is graded P of T P plus Q. Okay, and so this is going to be equal to FP, and then we have let's say T P plus Q over FP plus 1 TP plus Q. And this is equal to FP, and we have a big direct sum. Let's say I plus J is equal to P plus Q. And then we have BI comma J. Sorry, I'm going to write down the filtration now. Divided by, then we have this direct sum. I plus J is equal to P plus Q. BIJ. Sorry, I have to write this down every time. And then, what do we get? So we want I to be bigger than P. Okay, so I is the first component. Okay, so that's the vertical direction. And so what it's saying is we fix a P here, and then we're going to go look at all this stuff up here. Okay, and all right, and so now we do this. So this is I is greater than P plus 1, and so what this does is it takes B. We start it at P. The worst I could do is P, and then so we need it to equal to P plus Q. So we do this, and then P only goes up, and Q goes down, and we get this crap. Okay, so we have this thing all the way down to P plus Q 0. And again, we have B, P plus 1, Q, okay, minus 1. Okay, and then we can see that this is what's going to happen, and this is just B, P plus Q. Okay, so this is the right way. And then we're going to start going. So this is going to make us start going sideways here. Okay. So so we're going to be looking. So when we do the double complex spectral sequence, we'll go sideways. Okay, let's look at the E1 page. Okay, looking at the E1 page. Sorry, this thing I was supposed to do. Okay, so E1. So E1 PQ. And we saw that E0 was just this graded piece. So it turns out that we take cohomology, so this is just really HP of, so now we take the complex associated to the pth gradation plus Q, Q, not G. Okay? And so this is what we have. And so I want to give a description of the connecting homomorphism. So let's look at this. And so the description of the connecting homomorphism is this short exact sequence to the long exact sequence of complexes. So if we have an exact sequence of complexes, and let's do this. So let's notice that we do have a certain special exact sequence of complexes, Fp plus 1, and let's say K bullet, Fp plus 2, K bullet. This goes to Fp bullet over Fp plus 2 K bullet. And then we can put this, so this complex, P plus 2, P plus 1. Okay, so this is the smaller thing. The higher the number, the smaller. And so this feeds into here, and then we quotient out by not so much, but here you'll notice that we have the graded, this is a 1 here, the pth filtration of Kp. And then this thing is the P plus first of Kp. So this tells us this is a short exact sequence, and then there's an associated long exact sequence where we have connecting homomorphisms. So when you have a short exact sequence, you know, you have these H0s, and then it whips around, and then it comes down to the higher one. And so this tells us that we get, in the long exact sequence, we get these connecting maps, K bullet, to Hn graded piece plus 1 K bullet. Okay, so we have these short exact sequences. So maybe we can actually, so what we can do is, so now we have this information, and we may need to twist by Q, and we may need to do a little bit more. So what do we do? Here is what we do. E1 PQ is equal to HP, the pth graded piece of this complex, but we twist it by Q. Okay, and from the sequence above, we know, well, the twists respect the short exact sequence to long exact sequence. This goes to HP plus 1. Okay, because this was on the other end, to the P plus first graded piece now, because we're using the P plus first filtration of the same complex twisted by Q. And using this definition over here, this is just E1 P Q plus, or sorry, P plus 1 Q. Okay, so as in the first page, we started to go up. So this is on page 0. On the second page, here, we will start to go sideways. Okay, and then we'll eventually start going down, and so on and so forth. So that's all I wanted to say. So I want to put all the information we know about double complexes together. So what we're going to start with, the double complex. So B00, B01, B02, and I guess it could go on B03 if we're crazy. Okay, B10, B11, B12, B13, B20, B21, B22, B23. Okay, so we have all these objects, and they're connected by a double complex, or so like two D arrows. So they're going to be a complex in the up direction, and they're going to be a complex in the side direction here. Okay, so this is what a double complex is. we're going to ask that these things satisfy the following relation here. Okay, and then if we wanted to, we could have this thing go on here. Okay, and okay, we go like this. Okay, maybe we'll have it be truncated at the bottom for this example. Okay, and can I copy like this? No. Okay, so so we have this complex here, and to talk about the first spectral sequence, so this is actually the first page of a spectral sequence associated to a double complex. I think I turned it upside down. Can I get it to go back? Shit. Okay. Once again, I'm gonna try and stop. Oh, fuck. Oh, maybe it's up here. Shit. So I've managed to turn my page right side up, and I'm ready to finish drawing the pages. So I have this double complex here, and okay, I still have this double complex here. I guess. I need to mention that I pre-drew everything because I knew this was going to be a pain in the ass. So okay, so I'm just going to kind of show you what the pages of the spectral sequence look like. So okay, so for the first page, well, we just have identically these things on the spot for the double complex, except for now the arrows are going to be different. And here, we're going to go only use the side arrows. Okay, so we're going to only use the side arrows. Okay, and so we have this complex here, and then we take cohomology of each of these things, and then we get the next page. So I have the next page. Okay, and after doing this page, so we have this cohomology, and we do kind of a short exact, long exact sequence with the filtration. And this is with the filtration going from the top. So we use this filtration where we cut this thing off at, you know, this side, so a certain side, and then only look at things going up. So that our pieces here we'll only pick out, so like in this one here, we'll only pick out, along this sequence here, we'll only pick out this one. Okay, so then using that, we have this cohomology now, E1, and we saw that when we do this, the short exact to long exact sequence thing, all the arrows will start moving up. Okay, so this is what the first page will look like. Okay, so we get everything like this, and then now we're going to do cohomology again, and when we do cohomology again, we go up and over. Okay, so when we go up and over again, so here now we're going to go like this. Okay, so now these will be the maps, and we'll go out here, and so this one's going to go down like this, and so on and so forth. Okay, so this one goes here, and the arrows are getting longer and longer. So we have arrows for all these guys, but I'm not going to draw them all. Again, this is the second page, and now the explicit description of the map is given on the theorem that I stated, where we constructed this from the filtration. And I guess I don't know a quick short exact sequence to long exact sequence trick for this. But the good news is most of the time, you won't even need to go this far. You won't even need to know the map, because a lot of the times it'll, you know, we know that this thing will be, these maps will be 0. And which we're going to talk about that in another thing. Okay, and then for, you know, for fun, I pre-prepared the last third page. Okay, so this is what the spectral sequences look like here. Yeah.